Okay, here goes another easy question. Single regressor case where x is scalar and as usual, like we assume full rank assumption here, and this is just part of the exogenate assumption, right? The true exogenate assumption is about covariance between x and u, but that is unknown. We do not make any assumption about delta, right? The covariance between x and u. Now, suppose part A, suppose that alpha and beta are the true values. Find the observational equivalent but different parameter when delta is not zero. So let's think about this. We did it pretty like in an earlier question. Yi equals to alpha 0 plus beta 0 xi plus ui. What we are going to do here is we are going to, so truth, suppose that truth is beta 0 and delta 0. And I'm going to consider any delta that is different from delta 0. Then I will find corresponding beta tilde. So that's my idea. Beta tilde and ui tilde, right? How can we just need to construct beta tilde and ui tilde so that the linear relationship still holds, okay? So the idea is the same. We are going to add this much to u, right? So if you add this much part to there, then expected value of xi ui tilde, I'm sorry, oh, it should be divided by variance of x. Okay, so if you have to add this much, then the covariance, its covariance with x equals expectation x ui plus delta tilde minus delta 0 covariance x over variance of x. So it will go away, and this is delta 0. So in the end, we get delta tilde. So ui tilde will correspond to delta tilde. Now we have to find beta tilde to maintain the linear assumption. That is yi equals to alpha 0 plus beta 0, like here I will leave it blank. What we are doing here is we are adding this guy to the error term, right? Delta tilde minus delta 0 x over variance of x, right? That means we have to subtract it to the second term here, right? That means I am going to write it this way. If you write it this way, this is always true. Whenever this is true, then this is true, and you can rewrite this as alpha 0 plus beta tilde xi plus ui tilde, right? So definitely beta tilde is a different value from beta 0, but it still satisfies all the assumptions. It's linear and like full rank assumption satisfied. Just the covariance between x and u tilde is different from the covariance between u and x, the original ones. Okay, that's how we find observationally equivalent parameters. Second part, you make the standard exogenate assumption, which is wrong. Derive the misspecification bias. Now, if expectation of x ui was 0, then you would use this result. This would be your approach. Again, this is estimand, and this is your parameter, right? And what I'm going to do is, if this is delta, which is not 0, then I will recalculate the estimand. Right? So I will use the linear assumption. Now covariance between x and alpha is 0. Covariance between x and beta x will be simply beta 0, and covariance between x and u is not 0 anymore. So this much is just full bias. That's it. Like, you may use delta. Covariance is delta. So delta divided by the variance of x is the bias. Okay. And consider another variable z such that uncorrelated with u and covariance between x and z is not 0. Then prove that. There are several ways to show that, but I'm going to start from here. Let me try this way. Covariance between z and y equals covariance z alpha 0 plus beta 0 xi plus ui. And you can write this as z alpha covariance is 0, z and x beta times covariance z and x, plus covariance between z and u is also 0, so there is nothing more. That means beta 0 equals covariance of z y divided by covariance of z x. And this is possible because the denominator is assumed to be non-zero, right? I think this is all.